we're going to look at solving compound inequalities, which is just like when you take two inequalities and put them on the same graph in the same problem. So there's two types of compound inequalities we're going to look at. The first one would be like an AND statement. An AND statement is true only when both inequalities, I'll abbreviate inequalities, are true. And this is known as an intersection. An intersection, which we'll see in just a moment. So if we took x is greater than or equal to 3, we're going to go on 3 with a closed circle and shade in the positive direction. And if we said x is less than 7, so open circle on 7, shade less than, we want the intersection, which is where these graphs overlap. Oh, not that one. Let's see if we can focus in on these notes a little more, which is when they overlap, which is what we want. So we see that they overlap. We include this and here, and we go in between, which we would write as the set of x such that 3 is less than or equal to x, which is less than 7. Or we could say 3 such that x is greater than or equal to 3 and x is less than 7. So if we have this inequality where 4 is less than or equal to p minus 8 and p minus 14 is less than or equal to 2, we're going to solve each. So I'm going to add 8, and so we have 12 less than or equal to p, add 14, and we see p is less than or equal to 16, and this is an AND, which I'm going to put in set builder here and see I'm going to combine it like here. I have 12, I have to mirror this sign, so that becomes 12, and 12 is less than or equal to p is less than or equal to 16. I don't have to mirror that because we're putting it right there together. So when I graph, let's say 12 and 16 live out here, they're both closed circles. It would be the intersection of when p is greater than 12, so that would go this way, when p is less than 16, so that would go this way, and we would shade in the middle. Now, if we look here at 2 is less than or equal to g plus 4 is less than 7. This is an AND statement hidden here, so what I'm going to do is I'm going to rewrite 2 is less than or equal to g plus 4, and g plus 4 is less than 7. And I'm going to solve each side, so minus 4. So now I have negative 2 is less than or equal to g, and minus 4, g is less than 3. So when I combine these, because it's an AND statement, I'll have g such that negative 2 is less than or equal to g is less than 3. When I graph, I know I'm going to have a closed circle on 2, an open circle on 3. This is true when g is greater than negative 2 and less than 3. So it's going to be this zone here in the middle. The other type of compound inequality we can have would be an OR statement. This OR statement would be true when at least one of the inequalities are true. And we can think of this as the union. This is a union. If we have two graphs, it's both of those. So if we have x is greater than 2 and x is less than negative 1, when we take the union of these graphs, we put both of these together and we take all of the other. So we go this way and this way. And for OR, there's no way of combining it inside the set builder notation, so we just say x such that x is less than or equal to negative 1 or x is greater than 2. For OR statements, we do not write it all in one inequality. There is not one inequality for all of them. So if we look at a plus 1 is less than 4 or a minus 1 is greater than 3, I'm going to solve each one so I know that a is less than 3 or a is greater than or equal to 4. So we have the set A such that a is less than 3 or a is greater than or equal to 4. So let's say we have 3 and 4. We have a is less than 3. And on the same one, we have a closed dot on 4, and it is greater than 4. Now, a is less than or equal to 9, or 2 plus 4, that should be a. 2 plus 4a is less than 10. So a is less than or equal to 9. Great, I'm going to leave that alone. I subtract 2 and have 4a is less than 8. I divide both sides by 4, and I now have a is less than 2. Now, we have a is less than or equal to 9 and a is less than 2. We have to do a little bit of critical thinking, because when we go to put it in our final answer, if we were to graph both, we have 9 and 2. If we do 2, open circle going down here to the left, and if we have 9, closed circle also going down to the left, and we want the union, we want both of these graphs. What does the union of both of these graphs looks like? It looks just like when a is less than or equal to 9. So, in this case, even though we have 2, our solution is just a is less than or equal to 9. It's a little tricky, so make sure you ask questions or rewatch or think, if we include both, the intersection of both, or the union, this is a union of both. We want just the simplest way to say all of that, and that's a is less than or equal to 9. For our practice for tomorrow, we're on page 752, numbers 6 through 15. Number 6 says f minus 6 is less than 5, and f minus 4 is greater than or equal to 2. So I'm going to go and solve both. So we add 6, so f is less than 11. I'm going to add 4, and f is greater than or equal to 6. When I put this all in set builder, I see we have the set f such that 6 is less than or equal to f is less than 11. Take some time, practice how you put each of those in that notation. So we have the set f such that 6 is less than or equal to f is less than 11. I'm going to make a number line to graph. Let's see, we have 6 and 11. We have f, we know f is greater than or equal to 6. We know that f is less than 11. So our graph is going to look as such. Good luck.